Buenos dias, pre-calculites, and we are going to be talking about the law today. Yes, the law. And it's the law of sines that we're going to be doing. Now, you may have already discovered this in the web quest, but our objective is to show you the law of sines to find missing sides and angles of an oblique triangle. Yeehaw! Let's get going. I fought the law and the law won. One little tip before I even get started is when you are doing these solving triangles, which means finding all the missing sides and all the missing angles, when you're solving a triangle, please keep in mind, especially when you're using this law of sines, if you will do the acute angles first, that will help you. So here's our triangle. Solve this triangle. Now this is a right triangle, but the ones we're going to be solving are not going to be right triangles. So solve this triangle if you've got the measure of angle A equal 46 degrees 10 minutes, little a equals 27.2. These are ones that you have already done before. We know that we can find the measure of angle B by subtracting 4610 from 90 degrees. 89 degrees 60 minutes is the same as 90 degrees. And so we get 4350, bada boom, bada bing. So we've got measure of angle B. And then we need to find little b and little c. Since this is a right triangle, we can use SOHCAHTOA in order to do that. I'm going to do the tangent of 4350 equals little b over little a. So b over 27.2, multiply both sides by 27.2, bada boom, you got little b. Now for little c, I would use the sine of 4610. That's what I would do. Let's see what I did. Yes, that's what I did. Sine of 4610 equals 27.2 over c. And then remember, the shortcut is the sine of 4610 and the c can change position. That's a shortcut. But if you take it the long way, you multiply both sides by c, and then you divide by the sine of 46 degrees 10 minutes, and so on. So we end up with approximately 37.7. No problemo. You know how to do that. What do you do if you don't have a right triangle? That's what the law of sines was for. So it's for solving triangles that are not right triangles. So the law of sines says little a over the sine of a equals little b over the sine of b equals little c over the sine of c. In other words, these the sides and the angles are in proportion like that. Notice that little a is opposite the angle a. Capital letters are angles, little lowercase letters are lengths of sides. Little a and angle a, they're opposite of each other. This angle is opposite this side. So you can set up your relationship that way, and you're going to take the law of sines two fractions at a time to form a proportion. So we say this is used for, which I already said, finding missing sides or angles of non-right triangles, or oblique triangles, if you will. All right, let's solve this guy. Solve for triangle ABC. Give the lengths to the nearest tenth. Give the measures of angles to the nearest 10 minutes. So I have told you before, you always want to find the acute angles first. In this case, you have angle A and angle C. I like to draw a triangle because you know that the law of sines is opposite side over the sine of the opposite angle. So I've got 71 degrees, 62 degrees. I know I can find angle B right away because the angles of a triangle have to add to 180. So I'd end up with 47 degrees. Then that's going to be my angle B. I have little a is 20. So now I have all three angles, and I have this angle and the side opposite this angle, so I can use law of sines to set up a proportion. So I'm going to set up little a over sine of a equals little b over sine of b. So these are the angles, the capital letters, the measures of the angles. So we'd have 20 over sine of 71 equals little b over the sine of 47. Shortcut for solving a proportion. You multiply the two numbers that are diagonal to each other, divide by the third number. So we'd end up with 20 times the sine of 47 divided by the sine of 71. If you need to take it in two steps, take it in two steps. So when we do that, we end up with approximately 15.5. Little c, we're going to set up the same way. I like to use the side that I was given because I didn't round that one. So I'm going to do 20 over sine of 71 equals little c over the sine of 62. Be careful that you go opposite like we did here. Multiply by the sine of 62, you end up with 18.7. And that's it. Okay. So this is what we're going to be doing. Let's look at the next one. Now this one, they give you two angles and one side again, but you don't have the opposite angle, so you need to find that right away. You've got minutes this time, so we'll have 180 minus the sum of those two. So we find little a, angle A first, and you end up with 57 degrees 16 minutes. Again, I like to draw a triangle and I like to label the sides. So alright, so I've got little a is 400, and I know angle A is 57 degrees 16 minutes. So these are opposite of each other. So let's start with the law of sines using little a over the sine of A equals little b over the sine of B. So we're going to end up with 400 over 57 degrees 16 minutes equals little b over sine of 74 degrees 54 minutes. Multiply both sides by the sine of 74 degrees 54 minutes. Bada boom, bada bing. You get b is approximately 459. So that one's 459, and now we need little c. Again, I would use angle A and little a because I didn't have to round. And if you do that, you should get little c is approximately 352.4. Recall from your geometry days that the longer the side, the bigger the angle over here. So the smallest angle should be opposite the shortest side, and the largest angle should be opposite the longest side. Alrighty, I think you're ready to rock and roll. And again, as I told you, when you're doing the law of sines, find the acute angle first.